Hello, everyone. Welcome to the show. This is the second part of an eight-part series where we're going to be talking about sustainable communities and how to design them. So, in today's session, we're going to talk about going beyond walls and understanding alternative materials that can be used in the building envelope. And today we have with us a very special guest, Meenal Sataria. Meenal has over 2 decades of experience in research, design, development, and execution of climate action programs through the lens of decarbonization, net zero, and regenerative design, circular design and economy, and social impact. Meenal is working actively to develop the ecosystem for the decarbonization of the building sector from a standpoint of energy efficiency, systems efficiency, and circularity, and spearheading freight and passenger electrification in India and Southeast Asia. Meenal has worked extensively in providing solution based approaches to the critical challenges in the building sector, that is, the high performance building design, post occupancy modeling, and grid interactiveness. She also works strategically in the demand flexibility and demand side management areas. In the past, she has provided strategic leadership and governance to climate action projects as well as organizations. She has a Bachelor of Architecture from the University of Mumbai and a Master's in Architecture from the University of Arizona. In the past, she has served as a chair of the Faculty Development Programs and the program director for the School of Built Environments at Atlas Skill Tech University, where she was the co-founder of the New Materials Research Center, NMRC. NMRC provides a platform to discuss the issues of sustainability through the lens of new material design and material systems that are practiced in local, national, and global societies. It promotes circularity in design economies using practice based research or research by making, which is at the intersection of design, science, and ecology. Hello, Meenal. Welcome to the show.
Hello, Deep. Thank you so much for having me here.
Happy to have you. So, in the first part of this webinar, we're going to watch Meenal's presentation about alternate materials and the building envelope. Over to you. Uh, we're not able to hear you, Meenal.
I'm sorry. Yeah, can you hear me now?
Yes.
Yeah. So I was just telling our fellow passengers on board here, people on board here. This is less of a presentation, more of I think conversation and more trigger to help us think beyond. And I think we have a lot of solutions on board of the world, but what really required is a reset in a lot of thinking processes in the way we do our things. And that is what we're seeing today. That is what we are noticing today that is happening across worldwide organizations in the private sector, in the vendor community, as well in the innovation community. So I would highly encourage everybody to look at this presentation from an innovation standpoint and questioning standpoint, because there are several material products out there, but are we asking the right questions towards design? I think that is very important in it. Having said that, I'll start sharing my screen. Yes, I hope you can see my screen. I can see the screen. So, thank you everybody for having me here. This is going to be a short presentation of about 10 to 12 slides on unconventional materials or the approach to unconventional materials. And this is, I'm hoping to play a video after. So I will enjoy the presentation. I hope it makes all of us think because we not have to think about how we did things in the past or what we are going to do now. I think it's very important for us to think how are we going to think right now to do things for the future. So starting with in a material world, you rethink the building blocks of tomorrow. So we have a lot of new age materials technology, and this explosion is really on the way across the country, across globally, in Europe, in Norway, in so many places, within so many organizations, only just research organizations. I see a lot of private organizations, private design organizations also doing this kind of exploration. So why is this necessary? It's because we want to find the wisdom in the old ways. We do not want to forget the way we did in the past, but we really need new pathways because if we were doing something right, we would have actually solved this problem that we are looking at today. And what are problems? I think re-questioning or redesigning or redefining our problems is very important because if we redefine our problem, we get to the right answers. Without that, it is going to be difficult for us to arrive at the right solutions. So it is about questioning the fundamental conditioning of the values of the 20th century that are from industrial revolution, industrialization, and digitization. So what was the past? A simple question to everybody, and I'm sure all of you know that up to the 20th century, a little up to the 19th century, if you can say so, we put things on site based on what was available locally. So extracted from locally, we procured locally, we assembled locally, and we constructed locally. So that is how we did all these, right? And during and up to the first century, up to the industrial revolution, mass production, there was a slight shift that happened in the way we address materials and technology, or the way we materials and technology. So we did offsite. I mean, the site where our projects are located, we may not have materials located there. So we did extract offsite. We did procure offsite, but we still assembled and we still construct on site. Now, what happened because of this is, this is the seed of industrial revolution where everything was about scale, mass production. And mass production is a word I think we should take very, very seriously. There are some very simple words that we need to take very seriously. And due to digital revolutions, due to a lot of industrial revolutions, there was a lot of mass production. Manufacturing and product assembly process were highly optimized, no doubt. So process engineering was highly optimized. However, the value chain, as we call it, as a value chain, the product value chain from gate or gate to grade, right? Gate to grade is from the manufacturing gate all the way up to from the construction gate, or from the construction gate to the end of life that product or material or assembly was being neglected. So all we did was how to optimize our processes to make sure that we had mass production. And the second thing which we did, which was great, a boon as with curse, was mass standardizing. So one size shoe fits all. So it led to a compromised assembly of construction and building construction. And this is something that I call designers and architects who are present here will agree that to increase the profitability, mass production and mass standardization, which was a mantra for product design, was actually adapted even for construction and construction. I think that is where a lot of issues started coming up. We're still seeing other issues. We're still facing those issues. So business scale and standardize, no doubt about it. There's a certain economy to the scaling that happened, which led to a lot of unchecked resource consumption. And this is something that is known to us: environmental damage and unchecked waste. Waste is something that, so we have to look at materials. When we look at materials, we have to look at things. One is unchecked resource consumption and unchecked waste. So we have to look at both sides of the spectrum. Having said that, what can happen now, or what's happening now, is we have the user at the center of design of new materials. Can we do that? Can we bring it from the user standpoint and not from a production standpoint, or not from an industry standpoint? Just because an industry wants to mass scale a product into something else, what, that's the product we want to use because that's the only product available. But does the user need that? In other words, does the project need that product? So can we bring the power back to the user, or can we bring the power back to the people? Before I even take it to the user, I want to bring it to the designer. We would like to ask the question, can we bring the power back to the designer? So rather than giving the power to the vendor, let bring the power back to the designer. And it is said by a very famous economist, Jeremy Riff, is that small and medium-sized enterprise will flourish in this new era of manufacturing, and global companies will increase. They will metamorphose from producers and distributors to actors. So in this new economic era, role will be to coordinate and manage multiple networks and move concentrate across the value chain. If there is one thing that is extremely important today to be looked at, or is environmental concerns are concerned regarding buildings and building waste and building management and resource consumption, to scrutinize the value chain. So we are looking at these isolated bits of embodied carbon. We are looking at operational carbon, end of life carbon, transportation carbon, but we are not looking at the complete value chain, the complete value chain. It is not only the supply chain; it is all the way from the beginning. So it's very important to look at that and understand that from an economic standpoint. Just a question to everybody, or just a thought that I should just leave with you at this point, everybody, is that we know we have unchecked resource consumption. And having said that, at some point in time, we are going to run out of resources. And right now, where is all the waste going? So where is all our resources? It's either already built into buildings and built environments and infrastructure, or it's already down in lands. So we have not created a resource bank. And I would everybody to think from the point of view that can you do your construction as a resource bank, in which you can actually bank your resources and make it available when you need them? Can we actually create a cycle? It's like banking. Can you create a fixed asset and say कि ये 10 साल maturity के बाद ये material मुझे वापस मिलने वाला है? We actually do that. Having said that, when we start looking at materials very differently. So from that point of view, can you, instead of looking at mass standardization, look at mass customization? Why can't we look at mass customization, and why can't we bring a certain democracy to design? Democracy to design is where we ask the most feared questions and we go back to that. So it is, if we want to go back to circular economy, if we go back to sustainability materials, if we want to go back to understanding the performativeness of materials, we want to go back to nature, we have to reconceptualize and reframe the logic of material performance. Now we're going to ask some very tantalizing and very sensitizing, sensitive, as well as some very fun questions at the end of this, which many of them are going to disregard also and say this is not possible. But much of it we'll see today, as well as you will see that it was not possible 10 years ago, but it's possible today. So, let's think out of the box. Let's think more innovatively and see, can we raise a question? Can we reframe our logic for what we want to consider as material performance? Because we say beyond walls, and we want to look at the performative nature of materials, be it thermal performance, be it the longevity of our materials, be it the strength of our materials. What is that logic? Why are we stuck with the same logic which has been with us for 2000 years? Can we rephrase that? Can we read that? And what is that impact technology? We should not ignore the impact technology when we look at our building law for green futures, right? Because now we want to get definitely on-site digitization, automation, artificial intelligence, production assemblies, construction assemblies. We want to look at all of what's happening on site as well as off site. We want that democracy to come on site. There is a lot of robotics that is happening and that is upcoming, and that will not only be in manufacturing, but also in assembly as well as in construction. And many of you are very much aware that the new age of mass customization, user-centric design, user controls, where the user is able to create their own designs, their own homes, their own small built environments. I'm not talking about expensive environments here, but we talk about some very simple built environment. The control goes back to the user. Can you go back and assemble? Can we do it? I don't want to call Lego, but can you do it like, another? Can the user go and do IKEA kind of a thing, but a much sophisticated thing to their own built environment? Now, be it whether it is a small, we are looking at refurbishing, we are looking at renovating, or we are looking at a new construction altogether. So we may, look at our entire way of re-looking at materials, but we can't only look at materials, we have to look at technology, and we can't only look at technology because we have to look at assembly along with that. So can we look at all these things to rephrase and reframe our logic, where we can have an off-site automation, artificial intelligence in our production, no doubt about it. But the production is such, and production may or may not be a fine material, and it brings the material you on site such that you can customize the material to let the material become what it wants to be. There are many materials today exist in the built environment that are forced to become what they cannot be, or they are forced to become what they should not be. For example, certain kind of insulations, certain kinds of external cladding, and we may do that for their aesthetic purposes, but they fail in terms of their strength, in terms of their performance, in terms of their thermal performance. So we always say that a new material thing, in the age of new materials thinking, is that you should let the material be what it wants to be or what it can be, rather than forcing it to become something. And you have to start adding a lot of things like materials which become difficult to separate. You add a lot of heat, you have to add a lot of pressure to strengthen it and to make happen into something else that it probably does not have that strength to become on its own. For example, mud has the strength to become something really strong on its own. You do not need to add a lot of heat and pressure at a certain point in time. But certain other materials, like fly ash, on its own cannot be factored and needs a lot of heat and pressure to become into a well, then, for it to go away also, you'll need a lot of heat pressure to send it away back into the grave or back into the built environment or back into the manufacturing industry, which means you're increasing a lot of process energy, you're increasing a lot of process carbon. Having said that, I would just like to use out the really larger questions which I would like leave you all as we move forward in the conversation. First is let's ask ourselves, can the materials be allowed to age out of design? Yes, we do understand that 2,000 years ago, we want our buildings to last forever. We want architecture, our built environments to last forever. Why? Because we are very benign about the understanding that, very conscious that we are mining these resources. But then we are going to run out of them very soon. So which means we think separately that we need to make these resources available much faster than 500 years or 100 or 1,000 years or 200 years or 100 years. We may run out of certain materials, and it means that we need to create material banks which make it available to us much faster. The thing we're going to go and break down buildings, maybe not, but 50 years down the line, you may hear the next generation say that the age of this material is only 20 years. After that, it goes back to a material bank of the construction industry, and it's going to get reprocessed or recycled or refurbished to be something else. So let's think about it today. Can durability be looked at with material longevity? Durability and material longevity are very simple words, but very important for us to look at as a designer. And material life we decided only as necessary. Some materials need to stay for 100 years, but some materials can go away in 5 years. Why do those materials need to be here for hundreds of years? For example, a toothbrush. Now, a toothbrush is not a material of the building industry, but there are several materials in the building industry. I can assure you that will stay in the environment for another 500 to 1,000 years, and they probably need to serve us over 10 years. So can we actually look at that? And can we actually design longevity and durability based on the need of that material, based on the need that material needs to stay with us for a long time, and after that it can get replaced, it can go back to the back. Can the age materials be designed for a cradle to grave like biodegradables? Can we actually design our materials and our material systems and our supply chains for that? Can some materials be designed for cradle to cradle approach, and waste of one becomes the source of another? I think that is the one that is right now being followed a lot product design industry, a lot designing of products and the designing of materials, be it for the construction industry or be it for um, the larger product industry as a whole. And finally, is it all of the above, or about material consumptions, or is it just about material consumptions? That we have some very scary statistics that says that India has rebuilt 40% or 50% of its built environment. Another 50% is yet to come in the next 20 or 30 years. As much as we look at it from an emission point of view, I think we should be worried from the resource point of view. Where is the resource for that 40-50% more of the built environment? We are already the most populated country. We are already almost most dense in the country. We almost have the highest built environment, the square footage of construction that exists within the country. So having that, as much as we have to worry about energy resource, we need to worry about materials also, because we will need materials available to us to be constructing these for 30 years. I can assure you, 30 years, just like you did not have sand available somewhere 30 years down the line, not have some of the materials which we are so taking for granted today available 20 years down the line. And we will have to either look at alternative materials, or alternative ways of using these materials, which is what systems design. Just quickly, material innovation, technology, systemic changes. This is exactly what we saw is waste as a resource for developing new materials, and that is where we start looking at the cradle to cradle or the cradle to grave approach, and we understand the life cycle management, but it can happen only and only if we understand the assembly of our materials. So, like we said, we have to look at materials, we have to look at the value chains, as well as we have to look at our construction assembly. If our construction assembly is not going to allow us to disassemble our materials cleanly, the disassembly of the material that goes back as a waste may or not be feasible for us to do. So, as important it is for us to bring about a good assembly, we have to think at it from the point of disassembly also, so that this entire circularity we build it, and we can look at our environments as potential material impact. That if we are looking at the next set of buildings to be demolished 20 down the line or 30 years down the line, can they be designed? Can some of it be designed as material banks such that they can come back to the material industry as a resource? Right now, most of it is going to that. So, what are those system changes that we can actually incorporate? So, it's not only material innovation, but systems innovation also that we look at. For example, impact of natural materials on health and being of people. If you look at, you have an old building system that's there, as you can see in the image, which is ignored, which is not taken care of, and if you actually explore with new materials, can actually create biophilic experiences, can reduce stress that can actually induce better air quality, it can improve cognitive function and smooth creativity, so on and so forth. A lot of work has happened in this. I would like to bring forth just a small project, and one of the companies which I will encourage all of you to look at is Snohetta. Snohetta is a Norwegian company, and Snohetta had tied up with NOMY domain to create mycelium, a material with soundproofing qualities, which is both naturally and resistant and 100% postable. And I have a short video which I would like to play after that to show you what this material is about. So this is about the way how people are thinking about new age materials, the application of them, and the disassembly of materials. Snohetta has a lot of other kinds of material research. You can look up on their website. Snohetta is SNOHUTA. Just some material research that that we have done in the past. At this point, I would really like to mention a very dear colleague of mine, architect Shreyas More, whom I have worked in the past for the past 6 years. We no longer are associated together to be working. We are in two different places. However, we've done some substantial and very exciting material research. One of them, which is called as the Green Charcoal, and the Green Charcoal was about developing a degradable block which used biochar charcoal in it, and used reinforcement for fiber as a reinforcement. So it also had its strength, and we wanted to create this approach that it could be biodegradable, which means it goes back to the environment. It also could absorb atmospheric carbon, which it did. And because it had natural loofah, it allowed the curve small plants and biosystems on it. And we were surprised. We did a prototype and testing that actually found a small ecosystem developing. So we thought these blocks were very useful. We may not use from a structural strength point of view, but then there are so many applications in the building industry. For example, compound walls, urban dividers, urban walls, non-structural elements that are there in the building. And they don't need to be kind of, they can be 10-year, 15-year life kind of elements, which very happily give biodegradable ecosystems, ecosystems that can thrive on that. So can you imagine our compound walls? Imagine the gray and the brown of the urban system, and it starts becoming beautiful green, and we have a thriving ecosystem that continuing in every building of in the dense urban concrete jungles that we have starts actually becoming these green ecosystems. So we're working on it from that point of view. The other thing that we worked on was again material and assembly, and looking at working with UNSW, that is University of New South Wales in Australia, their art labs, and looking at industry base to be used to create new material tiles. So what you can see on the top left hand was actually a lot of industry based. That was different of industry based. That was you create paper blocks, small paper tiles, and these are actually research projects tested and tried and tested students. These are some of the other examples where you can actually use um, performance materials, and you can actually bring like some fun and good element design. You can start using fabricating, digital technology, AI, as well as Grasshopper, right? Or so many tools that are available that allow you to do some fantastic linear as well as never before imagined kind of applications. And that led us to think that the green charcoal doesn't need to be a block. The green charcoal may be a mix. So that is where we come to the point where we started believing that let the material what it wants to be. So we actually persevere to make it a mix, and whether it needs to go as a cladding material, whether it needs to become a plaster, or it needs to become a block, is for the designer and the user decide. And of course, we have derived, and we would have loved to derive the recipes of each of these. We are there, but not there for any kind of scale up. But that was actually in the daring approach which we wanted to take, and because we welcome it was also nationally displayed in a couple of biennales and exhibitions. The Material Conference by Material Driven is also another form we may want to look at. They have a lot of material-based conference in material innovation for a better tomorrow, and this should help us think about if we want to use our building materials, our building elements. Yeah, having said that, I think I would like to play a short video for you, and then we can open the discussion. Just give a minute.
Informative presentation. I think there were a lot of interesting points that you mentioned out there. And overall, I think the part that I liked the most was where we're talking about harmonizing with the materials that we're trying to create and use. And especially when we're talking about the user and it being user driven. At some level, we also are understanding what it is that the users want, or sometimes the users don't know what they want, or that their thoughts can count towards deciding how materials can be created or produced. And so that was a very interesting aspect that kind of caught my eye, where we talked about the democracy of design. And in some of your big questions, which you spoke of, um, the aspect of involving the materials age into our design process, where one can design along with the life of the material. and especially in some of the purposes where you said that we can replan the way that we build our buildings in order to match the durability or to allow the material to die. I think those were very nice ways of saying that we can really respect the way that the material actually exists. And also, when we're talking about the life of the material, I really liked the idea of the age and durability, because I think there are some materials like laterite which actually can become stronger with age. So the more that it's exposed to the sun, the strength of the material actually increases with age, and that's something we can look at. And it's a very thermally massive material as well. So that's something we could consider or explore with other materials as well and understand their behaviors. And absolutely on point when you spoke about the embodied carbon of the material, where there is so much energy that goes on, before the material is actually available to construct the building. And the users usually don't actually see that, or they don't know about that. And as we start, having some of that labeling with our materials, some of the aspects where we think about uh, how much energy is it in totality, not just the energy required or not just the financial cost required to have the material brought on to your building, but also understanding how much energy has already been put into that material before it comes onto the drawing board where we're actually constructing the building. um, I really like the two examples which you where you talked about the green charcoal, and also where you spoke about snow hectare, where they're using mycelium to create insulation boards. And in that respect, I actually wanted to also talk about where there is, very recently the solar decathlon winners in India actually came up with a material where the blocks, they're hollow blocks, and they actually capture carbon. So there we're talking about finding materials that can also work towards reducing the carbon outputs of the building, and also understand how they can actually work towards a solution for our climate goals and for our carbon reduction. Um, right. Um, there were many questions that were extremely thought provoking, and I think that we all do definitely need to reflect on how we can do this. Approach building materials differently, make it more, get the people more involved with this process, and not just assume that we just have a few limited materials like concrete, steel, and burnt brick, and everything that we do kind of needs to conform and match that in order for our building to be viable financially or even structurally. So I think that's a huge area of exploration, and I think especially when we look at it from the carbon point of view, where buildings, we know that buildings contribute to more than 40% of our, the Earth's carbon footprint, then the materials in the envelope can actually play a huge role in so many different ways. And where we explore, how we explore that is something that we can continue to, find out and test out and experiment with until we can arrive at something which, multiple solutions that can actually address how our climate change goals are aligned to.
Yeah. Hi. Do we still play the video, or we move on to Q&A?
Yes, let's play the video and then we can go ahead.
Sure.
So it all started when Snøhetta approached our startup, Nomi. We're a company that's making new products from the root-like structure of fungi called mycelium. And asked the question, what if we could create a building material that didn't just take from nature, but gave back to it? Could we tap into the biointelligence of the fungal world and do things better? Using a forest fungus and waste products from agriculture, paper production, things like leftovers from wool and dairy whey, we literally grew a soundproofing material that is naturally fire resistant, produces no volatile chemicals, and is 100% compostable in nature. When Snøhetta designed the new offices of Sally for EY Doberman, that's really where our collaboration began in earnest. To create a material that performed industry standards, but gave an aesthetic that inspired curiosity and perhaps awe for the natural world. For me, fungi are amazing because they teach us how all of life is interdependent. That collaboration and working together is truly where innovation thrives. That they can help us think differently as we collectively create a better future. To go beyond just being sustainable and be regenerative. To not just be net zero, but net positive in our impact on the world.
Fantastic. That was an absolutely wonderful video. Thank you very much. So the regenerative aspect of that material is what really kind of makes it such a wonderful material replacement to our current polypropylene and insulation based on such non-biodegradable materials. And it's absolutely harmonized with the way nature would solve for such issues.
That I so should we start the discussion?
Yes, I would love to start the discussion on your presentation as well as that video which you just shared. Um, so one of the aspects that kind of comes up is how do we actually look at some of the aspects from the practical point of view and from the science and research point of view. So, on one of the questions is environmental benefits versus safety concerns. While supporters emphasize the environmental benefits of unconventional materials like reduced carbon and lower embodied energy, while opponents also express the concerns about structural integrity and durability and fire safety. And I think that was actually a wonderful example where you not only have your fire safety and all of those aspects there, but also you have the structural integrity in place.
Yeah, that's right. I think that is where we need to go back to sensitivity in design is to ask the right material questions. So where the structural integrity is important, we can't do many of these, so we cannot probably yet relook at these kind of questions. But where uh, where certain performance is required, have to go and address it. We cannot guess what performance is. But when those performances are not required, and I think we will be surprised when we start listing down our elements of concern, various elements from walls and the number of walls and the kinds of walls. We'll realize that only a few of these require kind of stringent performances. There are many of them which serve the purposes of partitioning, dividing, actually segregating, and there are various ways to really do that, which was done ways earlier in the way architects plan, in the way built environments plan. So I would feel that performance is where they need to look at. We just still derive more questions to answer better circularity questions, that get better circularity answers are as those kind of performative requirements are considered for some of the elements or some of the.
Absolutely, absolutely. I'm going to just switch through the next question, where we're talking about innovation versus standardization. And that was another point that came through in your presentation, where on one side, people who support the unconventional materials argue for flexibility in building design codes, and standards and standards that would encourage innovation, while critics also emphasize the importance of standardized testing, which the conventional materials have already been through, whereas the new materials and the alternate materials uh, would still have to go through that rigorous process of standardized testing and regulation to ensure the safety and performance of the building.
Yes. I think irrespective of no matter how innovative your material is, it has to serve its purpose. So it just cannot be there for mere innovation or aesthetics or just because wanted to be biodegradable or engineering. So innovating or during innovation, it would not make sense to not design it for its required testing. If it's required to have a fire performance, it has to go through its tests. If it is required for waterproofing, it has to go through required standardized tests, which are programmed, which are being used by all our codes. They could be national codes or global standards. So we have to conform to those standards as far as the performance of that particular material is concerned. So I don't think any company that is innovating any of these materials is actually neglecting that as far as standardization of testing is concerned. They know that they will have to go through that.
Right. And of course, there's also scope to come up with understanding, individual instances where the code could also be overlooked, or where there's an option to where the code can have some kind of space for some other, materials that can come in, where, the testing could happen as it begins, or for certain size of buildings, where they can initially be allowed to be, applied and tested. And then based on that, it could kind of grow. So, we could also explore different possibilities of reviewing the entire the select material standard testing for these codes, and also look at possible new materials that could replace or perform better if we're able to relook at the way we do our testing as well. Now, the next question is about renewable resources versus scalability, where unconventional materials often come from renewable resources, promoting sustainability. However, the challenges may arise in terms of sourcing these materials at a larger scale to meet the demands of widespread construction.
I think that is where democracy and customization come into picture. So mass customization. The idea is not to replicate even, but the thought process. So it's a huge overhaul and a huge change that's required if that knowledge and that wisdom is actually made available tomorrow. If designs and architecture schools and firms actually start getting equipped to be able to innovate their own materials in some small ways, which they do many times. They do as far as certain kinds of rural enterprises is concerned, or rural enterprising is concerned. I think many of us are very experimental there because we do not have many laws or codes that we have to abide with. So I think if we get a little bit more ambitious and a little bit more daring, and I think we upskill ourselves, being able to do that. Scaling of a particular material is not important. I think scaling of the idea is important. So maybe if we try that, I'm not saying that's the solution, just a thought process that and everybody can here. Please contest it, and I would love to hear alternative arguments. But we feel that it's not necessary always to scale a product. It's necessary to scale the idea and adapt it. So I think if that happens, we we'll probably not have the issue of scale, mass scale, mass standardization, mass production.
Right, right. I think you said that very well, where it's important to scale the material, not necessarily that we scale the material, but it's important to scale the idea. Absolutely right. Now, moving to the next question, where I think this is at the core of it, where we're talking about energy efficiency versus performance. While some argue that unconventional materials can enhance the thermal insulation and energy efficiency in buildings, the critics also raise concerns about the long-term performance and reliability of these materials compared to traditional options.
Can you repeat that? I lost for a minute.
So, on one hand, the unconventional materials can enhance thermal insulation and energy efficiency in buildings. But on the other hand, the argument is about the long term performance and reliability of these materials compared to the traditional options.
I think yeah, we're going circles with that same thing. We don't have those answers yet. Um, but I can assure you that the new materials or the new discoveries or innovations that are actually going on, um, and the companies that have actually discovered these materials, like Soeta is also up with the biochar block, and there are many such companies which are actually trying to attack research and development to take towards slightly larger scales of construction. I think in that case, those companies would probably have the understanding to whether this panel or this rock or this material, whether it can really scale up for like a tall building or whether it is only okay for a small rise or short construction. I think that's where the designer's wisdom, the designer's critical thinking, and the designer's int is extremely important. And I think the designer plays a very important role because at every point they have to reason their argument towards why they are doing what they're doing in design and why they're adapting what they're adapting. We cannot play a blind man's role anymore.
Right, right, right. Absolutely. Um, Now, my next question is about cost effectiveness versus affordability. So, when unconventional materials can vary in cost, with some being more affordable than the traditional options, and others can also be more expensive. And balancing the cost effectiveness with the overall affordability is a significant consideration when evaluating their feasibility in a sustainable building project.
Yeah. So I think this is actually a very question of economics. And for those of you who have some interest in economics, should actually go back to certain presentations of somebody called as Walter Stall. And he has written an excellent book, well as he has some great short videos on YouTube that are about the economics of scale. And things have become cheaper because of a certain production scale that has come, because of the scale that has come. But that also meant that it could only come so many qualities or attributes. So to scale up, they had to reduce sort of attributes, and that was the economics of the Industrial Revolution. He argues that economic model no longer be valid because we will not have resource itself.
Okay.
And very soon, we will have to start looking at a lot of these custom solutions and start understanding. We will have to look at new economic models. So the way we are looking at the economic model of a particular material being the cost effectiveness of a particular affordability of particular material being available, the entire industry may go overhaul of the way things are priced and why they are priced the way they are priced. For all you know, they are not priced because of their innovation, but they are priced because of certain other resources, like the unavailability of water or energy or certain taxation or carbon tax or something like that. So there is just not one thing that governs the pricing of a material. There are several other things, global conditions, economic conditions that is actually doing that. Think the custom and the individuals time is a very small component in basic of the material. Or the customization. People have this notion that customization makes things expensive. I don't think so that happens. Not anymore today. Today there are many other parameters which are very strong and driving from a climate change point of view, which drive the cost of a product today. So if you actually jump economics or the economic cost of product, it reaches the cost where it reaches is only and only because of a lot of these other parameters. People who would want to argue with it are still wanting to believe that the raw material for which the way the costing was 50 years ago is going to be infinitely available. The minute that raw material goes up, their entire cost structure is going to change. And that is where probably we will start seeing a very different economic model come in, because we are going to start seeing a lot of taxation coming into the picture as far as carbon. I know that's a radical change. It's not a straight answer. Right now, those materials are going to be less affordable. But look out for it 10 years down the line, you'll hear a very different argument as far as the economics of many of these materials. You'll hear a very
Thank you very much. That was a very good answer. I think while economic models are also changing, a way to kind of reconstruct our economic models or way of approaching the economy when it comes to building materials can also be relooked at in a completely new way. I think we have space for maybe one last question, which is when we talk about short-term and long-term considerations. So evaluating the benefits and drawbacks of unconventional materials requires us to look at both short-term and long-term factors. Like on the short term, we look at initial costs, capital costs, um, maintenance requirements, and potential lifespan becomes more of a long-term consideration. So, very often we know that everyone's wanting to kind of go by the short-term approach, but at the same time, the long-term approach is required not only from the durability point of view, but also from the cost and savings point of view when we talk about sustainability.
So yes, the short term and the long term, once again, from what we sense in terms of the way it has been in the last 3 decades or 4 decades, the way we've been looking at auction. The 50 years ago, 100 years ago, buildings last for 100 years. In the 3 decades, the way we are building, they're not last for more than 5 decades. I presume, I'm hoping that we build still last for at least 5 decades, but looks like it needs a lot of upkeep within a decade or less than that, right? We are designing for long-term, buildings are performing for term. I think first we need to address those things, what is happening and how that is happening. We are going to look at an upfront cost, of course, but upfront cost, as much of us and many of us know, in many parts of the world is land and not construction cost. So that is the short-term and long-term idea of the project. The way you want to look at costing of any particular project. Now, as far as the bigger picture or the larger picture is concerned, I think there is a lot of policy reform that is coming in because a lot of climate change perspectives, because a lot of decarbonization perspectives, because a lot of commitments and goals that a lot of countries, including India, are making towards these larger goals. And these policy reforms are going to reshape a lot of the industry. They're going to reshape the way we want to look at. We may be able to look at our projects as short term and term. We may have to look at them as mid term. We will have to live with that first initially, and we will have to rework on the economics of those projects. We will have to rework on the economics of construction of those projects. Maybe at that point in time, localizing will make more sense rather than actually globalizing. I think there is a lot of back to the design board that's coming very soon, because a lot of policy reforms that we will see and that we are seeing as far as all these environments are concerned, and not only just from a material standpoint, but from a resource standpoint. And then the way we need to look at buildings, like tomorrow, if circularity is built actually as one of the bylaws, I think it's going to change the way we design projects on the design board altogether. Certain materials will just not be used. Certain materials are going to be used. Construction assemblies will become different. So it's all about the way the policies are going to aim and reshape, and what is it that we are putting into priority. Construction waste is also something that in a lot of countries, including ours, is a very priority. All this while we were talking about resource shortage or resource consumption, but we also have to understand construction waste, which is a huge burden and a liability as far as the industry is concerned. And then, of course, there is emissions, and there's carbon, and there is additional carbon, and so on and so forth that we have. So, once again, I think the way I see a lot of new projects, new age projects, and larger conversations. Now, I'm not talking about that one small residential building house that's coming up, but I'm talking about the larger conversation. If we are looking at the government, looking at the reform at affordable housing, or at a very large policy level, state level incentive or something has to come up, then we have to look at these large level conditions where we may have to relook at our short-term definitions. And there is a very serious thought in the industry where a lot of top industries are driving the idea of circularity, because for their own longevity, for them, looking at recycled or waste as a source is much more cost effective than going mining new resource. So there's a lot of that is happening, a lot of economics of that is happening. Anybody's interested, you can actually go and talk to somebody in the industry, and go and talk to somebody in the cement industry. You will be surprised to know what is it that they put out for, they take parts of their resource base as well as, their raw material. And they're all moving away from actually mining things, from actually doing, because it's much more expensive for them. This is more easier. So they are actually welcoming the idea of circularity. So short-term and long-term is going to be redefined in short.
Wonderful, wonderful. I think that is actually quite a big game changer if we're able to move to a sustainable option, to a sustainable future, and it's cheaper for us, right? So I think that's kind of where we're trying to also move in all the different aspects of sustainability, not only in the building envelope, where we're actually trying to show and prove that we can do sustainable things, and it doesn't have to cost you more, and it could actually cost you less. And I think that is the argument which it's irrefutable for people to kind of move towards and to kind of accept and embrace sustainable approaches in their work and in their processes. So fantastic. I think that was a very good example. All right. So with that, I think we're going to close the webinar for today, and looking forward to more engaging discussions on this show, where we're talking about designing sustainable communities and the various aspects of expertise and insight that we require. Thank you very much, Meenal, for bringing so much insight into this show and talking about all of your experiences, as well as these informations about what people are doing out there with alternative building materials, and showing us how, this is only the beginning and there's so much more to come.
Thank you, Deep. Thank you so much, everybody, for taking time out on a Sunday evening to come and join us for this discussion. And do watch out for designing sustainable community. There are many more exciting conversations coming on board. So looking forward to many more of your conversations.
Thank you very much.